Hello everyone and welcome to this video channel Science for Class 8. Science for Class 8, and in today's video class let's study chapter number 6, Combustion and Flame. In the previous video class we studied the first part of this chapter number 6, Combustion and Flame. Today let's continue this chapter as a second part. In today's video class, let's study from chapter number 6, page number 69. Types of combustion. Let's see types of combustion. Here, bring a burning matchstick or a gas lighter near a gas stove in the kitchen. Turn on the knob of the gas stove. What do you observe? So here, what does it say? Let's see. We have to bring a matchstick or a gas lighter near a gas stove. Then we have to turn on the knob of the gas stove. Then what do you observe? And here, to do this activity, you have to take precaution. That is, do not handle the gas stove yourself. Ask your parents to help. So, to do this activity, you can take help from your parent. So, we find that the gas burns rapidly and produces heat and light. Then, such combustion is known as rapid combustion. So, when we switch on the knob of the gas stove and by using a matchstick or a gas lighter, then then the gas burns rapidly and it will produce heat and light. So such combustion is known as rapid combustion. So this is the first one, rapid combustion. There are substances like phosphorus which burn in air at room temperature. Phosphorus which can burn in air at room temperature. Room temperature 25 to 27 degrees centigrade is regarded as room temperature. So in this range of temperature, phosphorus can burn in air. Next, the type of combustion in which a material suddenly bursts into flames without the application of any apparent cause is called spontaneous combustion. Here we find another type of combustion, that is spontaneous combustion. Spontaneous combustion is also one type of combustion. In this case, a material suddenly bursts into flames without the application of any apparent cause. That is called spontaneous combustion. So rapid combustion and spontaneous combustion, these two types we have learned now. Next page, let's see textbook page number 70. In textbook page number 70, spontaneous combustion of coal thus has resulted in many disastrous fires. In coal mines, spontaneous forest fires are sometimes due to the heat of the sun or due to lightning strike. So, spontaneous combustion of coal thus and has resulted in many disastrous fires in coal mine. In coal mines, spontaneous combustion occurs as well as in the forest fires also. It is because of the heat of the sun or due to lightning strike. Lightning strike also one cause of spontaneous combustion. However, most forest fires are due to the carelessness of human beings. So, in the very rare case, lightning strike is also one cause of spontaneous combustion in the forest fire. However, most of the forest fires are due to the carelessness of human beings. It is important to remember that the campfires must be completely extinguished before leaving a forest after a picnic or a visit. So most of the people, they go visit for a picnic in the forest. Then when they burn something, when they burn dry woods there, then they do not completely extinguish before they leave that place. Then from that place, then because of the strong wind, then forest fires may begin from that place. Here it is mentioned in that way. So here let's continue. We generally have fireworks on festival days, particularly in the Diwali, say fireworks, and firecrackers we use. When a cracker is ignited, a sudden reaction takes place with the evolution of heat, light and sound. Yes, it is right. When a cracker is ignited, sudden reaction takes place with the evolution of heat, light and sound. Heat, light and sound is evolved when we ignite a cracker. A large amount of gas formed in the reaction is liberated. So a large amount of gas formed in the reaction is liberated in a sudden manner. Such a reaction is called explosion. So such type of reaction is called explosion. So explosion can also take place if pressure is applied on the cracker. So what does it mean? Explosion can also take place if pressure is applied on the cracker. So if we give pressure, if we apply pressure in the cracker, then explosion also can take place. Now let's see flame. Flame. What is flame? Let's see. Observe an LPG flame. Because of the nature of the fuel, flame can be of different. So let's see. Observe an LPG flame. Can you tell the color of the flame? What is the color of a candle flame? Let's see. Recall your experience of burning a magnesium ribbon in class 7. In class 7, we already know the burning of magnesium ribbon. Then you can just remember your experience you have come across in class 7. If you do not have experience of burning the remaining items, then in table 6.2 you can do that now. If you do not have experience, then you can do this table 6.2 now. Here table 6.2 says materials forming flame on burning. Here we can see serial number 1 to serial number 5 are given and materials are given like candle, magnesium, camphor, kerosene stove, charcoal, and forms flame, does not form flame. Here we can study in serial number 1 material. The first one is candle. Forms flame. Thus, when a candle burns, it forms flame or does not form flame. Yes, candle forms flame. So you can tick here. Candle forms flame. And point number 2, serial number 2, material is magnesium. When magnesium burns, does it form flame or does it does not form flame. So for this number 2, magnesium does not form flame, so you can tick here. And for point number 3, camphor, does it forms flame or does not form flame? So I think camphor doesn't form flame. And here kerosene stove, point number 4, share number 4, kerosene stove, so it forms flame. And point number 5, charcoal, does it form flame or not? Let's see. Charcoal, it doesn't form flame, so you can tick here. So in this way we can check about the formation of flame, or does it form flame or not form flame, like that. And here some pictures are also drawn. Figure number 6.8, colors of a candle flame and the flame of a kitchen stove. Here the flame of the kitchen stove is shown like this, and candle flame, it is shown here. And here also some flames of kerosene lamp, candle and Bunsen burner. This is the kerosene lamp, it forms flame, and candle lamp also it forms flame. And this is the Bunsen burner. So different colors, in different colors they form flame. The flame is not the same in color. So from this activity we know the formation of the flame and its colors. And next page, let's see. In next page, page number 71. Structure of a flame. Activity 6.5. Let's see. Structure of a flame. What does it say? Let's see. Light a candle. Here you have to take some caution, that is, we have to be very careful while doing an activity, otherwise you may got hurt or you may got injured. So not to happen like that, we have to take care. Light a candle. Hold a 4 to 5 centimeter long thin glass tube with a pair of tongs and introduce its one end in the dark zone of a non-flickering candle flame. Figure 6.10. Here one figure is also shown. Figure below. Okay, I will show you. In this case, what does it says? We have to light a candle and we have to hold 4 to 5 centimeter long thin glass tube with a pair of tongs. You know, a pair of tongs is we have to use a pair of tongs and introduce its one end in the dark zone of a non-flickering candle. So bring a lighted matchstick near the other end of the glass tube. Do you see a flame caught at this end of the glass tube after a while? If so, what is it that produces a flame? Notice that the wax near the heated wick melts quickly. So in figure number 6.10, figure is shown. Here is the burning candle, and we have to bring a 4 to 5 centimeter long thin glass tube. This is the thin glass tube, and here a tong is used. A pair of tong is used here. This glass tube we should not hold by our hand directly, so we have to use a pair of tong, and it is held by this tong. This glass tube is held by using this tong, and it has to introduce its one end in the dark zone. Here is the dark zone, and dark zone of a flickering candle here, and burning a lighted matchstick near the other end. In the other end, on the other end, say bring a lighted matchstick near the other end of the glass tube, and do you see a flame caught at this end of the glass tube? Here, when you bring a lighted matchstick, then here a burning should take place. You can see here. Okay, next let's continue. The substances which vaporize during burning give flames. For example, kerosene oil and molten wax rise through the wick and are vaporized during burning and form flames. Then the substances which vaporize during burning give flames. And for example, say kerosene oil, molten wax rise through the wick and are vaporized during burning and form flames. So these are what about the formation of the flames. Charcoal, on the other hand, does not vaporize and so does not produce a flame. So charcoal in this case does not vaporize and so does not produce a flame. In activity 6.5 above, could the vapors of wax coming out of the glass tube be the cause of the flame produced? Here, the vapors of wax coming out of the glass tube be the cause of the flame produced. Yes, it is. Here, figure number 6.11, we can see a picture. Here is the burning candle. Let's see. When the candle flame is steady, introduce a clean glass plate or a slide into the luminous zone of the flame, as done in figure number 6.11. Here, a glass plate we can slide in the flame of the candle, burning candle, or we can slide like this and hold it there with a pair of tongs. We have to hold it with a pair of tongs. We cannot directly touch this glass plate, otherwise it may become heated, and when we touch by our hand directly, then it may be so heated. Then hold it there with a pair of tongs for about 10 seconds. Then remove it. What do you observe? Then you can remove after keeping for some 10 seconds. What do you observe? Then dark spots, you can see dark spot here like this. In this case, in figure number 6.12, a circular blackish ring is formed on the glass plate or slide. A circular blackish ring here, circular blackish ring is formed, and it indicates the deposition of unburned carbon particles present in the luminous zone of the flame. So in the luminous zone of the flame, deposition of unburned carbon particles. Deposition takes place in the luminous zone of the flame. So in this luminous zone of the flame, when we put a glass slide here, then deposition of the unburned carbon particles are present. It shows in this activity. So hold a thin long copper wire just inside the non-luminous zone of flame for about 30 seconds, as done in figure number 6.12. Figure number 6.12 here. We have to hold a thin long copper wire. This is the long copper wire just inside the non-luminous zone of flame. Just inside the non-luminous zone of flame for about 30 seconds. And notice that the portion of the copper wire just outside the flame gets red hot. And we have to notice that the portion of the copper wire just outside the flame, the portion of the copper just outside the flame here gets red hot. Here you can see red hot. So thus it indicates that the non-luminous zone of the flame has a high, next page, high temperature. As you know, is a high temperature. In fact, this part of the flame is the hottest part. So this part is the hottest part in figure number 6.13. So hottest part of the flame is this, and this is the outer zone of complete combustion, that is called blue, and this is the moderately hot. This one is moderately hot, and this one middle zone of partial combustion, that is yellow color, and last less hot is this one. And here innermost zone of unburned wax vapors, that is black, and wax candle, this is the wax candle. So figure number 6.13, different zones of candle flame is shown here. So from this we know that the different regions of the flame, here goldsmiths blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. Figure number 6.14. Why do they use the outermost zone of the flame? Here, the outermost zone of the flame used by the goldsmiths. Why do they use the outermost zone? Because the outermost zone is the outermost zone of complete combustion. Complete combustion takes place, and that is the hottest part of the flame. Because of that, the goldsmiths blow the outermost zone of the flame. Here you can see one figure number 6.14, goldsmith blowing through a metallic pipe. Goldsmith blowing through a metallic pipe. Here a metallic pipe is here, and here is the burner, and the outermost zone of the flame they use to blow air, and with that they try to use to hit the gold. Okay, next table 6.3, types of fuels. Let's see, types of fuels. Table 6.3, types of fuels. Cell number 1, 2, 3, solid fuels, that are coal. Liquid fuels, kerosene oil. Gaseous fuels, natural gas. So cell number 1, 2, 3, solid fuels are coal, and liquid fuels here given as kerosene oil, and gaseous fuels here given as natural gas. So here you can mention solid fuels like dry wood. Solid fuels you can mention here one more, that is charcoal or cow dung, like that. And liquid fuels, here you can mention LPG also, liquid fuels. So gaseous fuels, natural gas, it is given here natural gas. Some others you can add. Then what is a fuel? Let's see, what is a fuel? Let's see what is a fuel. Recall that the sources of heat energy for domestic and industrial purposes are mainly wood. Yes, sources of heat energy for domestic and industrial purposes are mainly wood, charcoal, petrol, kerosene, etc. These substances are called fuels. So fuel means what? Any substance or material that can burn, that is called fuel. So a good fuel is one which is readily available. It is cheap, and it burns easily in air at a moderate rate. It produces a large amount of heat. It does not leave behind any undesirable substances. So here some characteristics of a good fuel is mentioned. And in common sense, what is fuel? We can say any substance or material that can burn is called fuel. So here are some characteristics of fuel. A good fuel is one which is readily available, it should be cheap, and it burns easily in air at a moderate rate, and it produces a large amount of heat, and it does not leave behind any undesirable substances. So these are the characteristics of a good fuel. There is probably no fuel that could be considered as an ideal fuel. Say, we should look for a fuel which fulfills most of the requirements for a particular use. That is, fuels differ in their costs. So many fuels are available, but their cost is different. Some fuels are cheaper than others, and some fuels are cheaper than others. Some fuels are costlier. Make a list of fuels familiar to you. Group them as solid, liquid, and gaseous fuels as in table 6.3. Here, as I already told you, in the table 6.3, fuel efficiency. Suppose you were asked to boil a given quantity of water using cow dung, coal, and LPG as fuel. Suppose you were asked to boil a given quantity of water, small quantity of water you have to boil using cow dung, coal, and LPG as fuel. Which fuel would you prefer? Give your reason. You may take the help of your parents. Do these three fuels produce the same amount of heat? No, they do not produce the same amount of heat. So the amount of heat energy produced on complete combustion of 1 kg of a fuel is called its calorific value. Here, what is calorific value? Let's see. The amount of heat energy produced on complete combustion of 1 kg of a fuel is called its calorific value. Here one term we face, that is calorific value. Calorific value is nothing, it is the amount of heat energy produced on complete combustion of 1 kg of the fuel. Then the calorific value of a fuel is expressed in a unit, that is called, the next page, that is called kilojoule per kg. In short, it is also represented as kJ per kg, kilojoule per kg. So calorific value of a fuel is expressed in kilojoule per kg. So calorific values of some fuels are given in table 6.4. Let's see calorific values of different fuels. Here fuel cow dung calorific value, that means kg per kg. Here 6000 to 8000 calorific value of the fuel cow dung is 6000 to 8000. And fuel wood it is say 17,000 to 22,000. And coal, the fuel coal, the calorific value is given as 25,000 to 33,000. And petrol, its calorific value is given as say 45,000. Kerosene 45000, that means 45,000. Diesel 45,000. Methane 50,000. CNG 50,000. Then LPG, it is given as 55,000. And biogas, so it is given as 3500 to 4000. Biogas 35,000 to 40,000 is the calorific value. And hydrogen, it is given as like this 150,000. That means 1500. It is given as like this. So calorific value is very high in the hydrogen. It produces enormous amount of heat. Next, let's see, burning of fuels leads to harmful products. Burning of fuels leads to harmful products. So what harmful products are produced by burning of fuels? Burning of fuels, let's see. The increasing fuel consumption has harmful effects on the environment. Carbon fuels like wood, coal, petroleum release unburned carbon. Carbon fuels. Which carbon fuels? Carbon fuels like wood, coal, petroleum release unburned carbon particles. Here, unburned carbon particles. These fine particles are dangerous pollutants, causing respiratory diseases such as asthma. So here, carbon fuels like wood, coal, petroleum release unburned carbon particles. So these fine particles of carbon are dangerous pollutants. They cause respiratory disease, particularly asthma. And incomplete combustion of these fuels gives carbon monoxide gas. And it is a very poisonous gas, carbon monoxide. And it is dangerous to burn coal in a closed room. In a very closed room, burning of coal is quite dangerous. The carbon monoxide gas produced can kill persons sleeping in that room. So, the carbon monoxide gas produced from the burning of the coal even can kill the persons sleeping in that room. Here, so that is why we are advised never to sleep in a room with burning or a smoldering coal fire in it. So in a burning or smoldering coal fire, we should not sleep in that place. It is combustion of most fuels releases carbon dioxide in the environment. You know, combustion of most fuels releases carbon dioxide in the environment. Increased concentration of carbon dioxide in the air is believed to cause global warming. You know, global warming, we frequently heard about this term global warming. So, it is because of combustion of most fuels, they releases carbon dioxide in the environment. And it increases concentration of carbon dioxide in the air and is believed to cause global warming. So, the main gas responsible in the global warming is carbon dioxide gas. Here, let's see point number 4. Burning of coal and diesel releases sulfur dioxide gas. Coal and diesel burning releases sulfur dioxide gas, and it is an extremely suffocating and corrosive gas. So, sulfur dioxide gas is extremely suffocating and corrosive gas. Moreover, petrol engines give off gaseous oxides of nitrogen, and oxides of sulfur and nitrogen dissolve in rainwater and form acids. So, such rain is called acid rain. Here we come across one term that is called acid rain. How it forms? In the acid rain, say burning of coal and diesel releases sulfur dioxide gas, and it is an extremely suffocating and corrosive gas. Moreover, petrol engines gives off gaseous oxides of nitrogen. Oxides of sulfur and nitrogen dissolve in rain water and form acids, and such rain is called acid rain. It is very harmful for crops, buildings and soil. You have already learned about it in class 7. The use of diesel and petrol as fuels in automobiles is being replaced by CNG. So in these days, use of diesel and petrol as fuels is replaced by CNG, compressed natural gas, because CNG produces the harmful products in very small amount. in a very less amount. CNG is a cleaner fuel. So CNG is also one of the cleaner fuel. Here some points are also present inside this. Let's see. For centuries, wood was used as domestic and industrial fuel. But now it has been replaced by coal and other fuels like LPG. So, in many rural parts of our country, people still use wood as a fuel because of its easy availability and low cost. Even in the rural area of our country, dry wood is still used because of its easily availability and low cost. However, burning of wood gives a lot of smoke. Burning of wood gives a lot of smoke, that is right, and which is very harmful for human beings. And it causes respiratory problem. Also, trees provide us with useful substances which are lost when wood is used as fuel. Moreover, cutting of trees leads to deforestation, and which is quite harmful to the environment, as you learn in class 7. As you learn in class 7, the term that is called deforestation. Deforestation means the cutting down of the large number of trees. That is called deforestation. And here let's see global warming. Global warming is the rise in temperature of the atmosphere of the earth. This results, among other things, in the melting of polar glaciers, which leads to a rise in the sea level, causing floods. In the coastal areas, low-lying coastal areas may even be permanently submerged under water. So, this is what about the effect of global warming. So, because of the global warming, the temperature of the atmosphere becomes rise, and it results, among other things, like say melting of polar glaciers, which leads to rise in the sea level. And because of the increase of the sea level, causing floods in coastal areas, particularly in the low-lying coastal area, and may even be permanently submerged underwater. Thereby, landmass becomes reduced. So this is the what about the effect of global warming. So for today, with that, it comes to the end of this chapter. In the next video class, let's meet again. For today, bye.